Hello friends, welcome to Learner's Planet. Friends, in this session I'm solving a good collection of questions based on algebra. Most of the questions are from previous year CAT papers and mock test papers of various institutes. So let's take these questions one by one, and once again my suggestion will be just read the question, just go through the question and try to solve it on your own, then only go through the solution which I am going to give. Okay, so this way you'll be able to practice with me. So the first question over here, if two quadratic equations ax square plus ax plus 3 and x square plus x plus b is equal to 0 have a common root at x is equal to 1, then which of the following statements hold true? Now what does this question mean? See, these two equations have a common root x is equal to 1. That means both the equations, they have the root as x is equal to 1. That means if we put x is equal to 1 over here, the value of this equation will be 0, right? And similarly over here, if we put x is equal to 1 over here, then the value should be 0, since x is equal to 1 is root of this equation, or we can say x minus 1 is the factor of this equation and this equation. Okay, so the simplest way to do this is we just put up the value of x as 1 directly. So what we will be getting, a plus 3 is equal to 0. Try to skip some steps, don't write if you don't need them. Okay, so here a plus 3 is equal to 0. That means 2a plus 3 is equal to 0. That means a is equal to, just a moment, 2a is equal to 2a plus 3 is equal to 0. That means a is equal to minus 3 by 2. Okay, similarly 1 plus b is equal to 0. If we put x is equal to 1, that means b plus 2 is equal to 0. That means b is equal to minus 2. Now we have got the value of a and b both, right? Now we can easily find out which of the relationship is true. Maybe one or more than one, since options we have is at least 3 relationships are true. Okay, so a plus b is minus 3.5. So minus 3 by 2 minus 2. So if we add both of them, this is minus 1.5. So minus 2 plus minus 1.5 is minus 3.5. So this relationship A is correct. So we can eliminate this. Okay, AB is equal to 3. Just multiply these two. So minus minus will be cancelled, 2 and 2 will be cancelled, so we'll be getting AB is equal to 3. So this is also correct, this is correct, this is correct. Okay, then A divided by B is equal to 3 by 4. So minus 2 divided by minus 3 by 2 divided by minus 2. So minus minus will be cancelled, so you'll be getting 3 by 4. So this is also true, right? So no need to check further. A, B, C true. So we just have one option only with A, B, C. So no need to check for D. Okay, so this is correct. I hope you are clear with this. Now we try this question. 1 upon a square plus 1 upon b square is equal to 29 by 100, where a and b are positive. Find 2 by 3 plus a plus b by a minus b. Now 1 by a square plus 1 by b square. See, if we just look at this relationship carefully, this equation carefully, what we can do is we can easily find out the value of a and b. See what is happening over here. 29 by 100, we can write down it as 25 by 100 plus 4 by 100, right? So this is precisely, no need to write, but I'm just writing for you for your reference. 1 upon a square may be 25 by 100, and 1 upon a square may be 4 upon 100, and 1 upon b square may be this or this, right? So we cannot get the unique values of a and b, right? So, we know that both of them are positive. So a may be 5 by 10 and b may be 2 by 10, or a may be 2 by 10, b may be 5 by 10. Okay, the square root of these two, right? Since we just have to take the positive values. But over here in the denominator, see, in the numerator it really doesn't make difference because both the variables are being added. But in the denominator, a minus b is there, right? That means we have to find out the difference of a and b. Now this difference may be positive, may be negative, right? If it is 5 by 10, if a is 2 See, 1 upon a is 5 by 10, so a may be 2, and if 1 upon a is 2 by 10, then a may be 5. In that case, a will be 5. So a and b 2 or 5. So we cannot get a unique value of a minus b. Maybe a is 5, b is 2, maybe a is 2, b is 5, right? So in that case, a minus b can produce maybe positive, maybe negative value, right? So uniquely we cannot determine the answer of this question. So it is can't be determined. Okay, I hope you are clear. Now see this question, simple one. Here 2 plus root 2, we just leave it as it is and take LCM of these two. So it will be 2 minus root 2 plus 2 plus root 2. So root 2 will be cancelled. So we are left with 2 into 2 in the numerator, and in the denominator we'll be having 4 minus 2, that is 2. Okay, so we are having 2 plus root 2 plus 2, right? So 2 times 2, that is 4 plus root 2. Simple.